Welcome to the classroom. Today we're talking about soil, or is it called sediment? People in the agricultural industry, soil scientists, they consider soil to contain organic matter. Geologists, on the other hand, and civil engineers, we consider soil to be any loose, unconsolidated sediment derived from rock. It could contain some organics, but not all sediment contains organic material. It depends on the depositional environment in which it's been laid down and whether or not there's been a pause in deposition to grow organic material. We can learn a lot by looking at the existing depositional environments that we have around us. But in the past, there have been different environments depositing sediments. Even right here in Toronto, Ontario, there used to be 3 kilometers of ice above us. And so we have a lot of glacial till formations, different landforms, not all of them made from till, but different soils deposited in different environments. We have more modern deposition happening in the Toronto area from rivers and streams, and down by the lakeshore, Lake Ontario, we have beach deposits. But if we go further afield out to the ocean, we have different depositional environments as well. And in desert environments, I was recently in the Gobi Desert. You can check out that video. What's the engineering link? We need to understand where the foundations of our buildings and our structures are going to be placed on. What is the sediment that it's going to be built on? And also we use a tremendous amount of unconsolidated sediment as aggregate in our construction materials, making concrete and cement and so on. I want to take you to a past glacial environment towards Peterborough, Ontario. There's lots of wonderful landscape features that were formed underneath the glacial ice. And in such an environment, we can get different types of sediment deposited. In a glacier environment, we can get an esker forming. This is essentially a river flowing underneath the ice. And when we have flowing water, we remove a lot of the fine material. It gets washed right down out to lakes and the ocean eventually, because those particles don't need a lot of energy to move them. What's left behind in the esker is all that coarse material, the cobbles and the gravel and the sands. And so we get buildup actually of the sediment. We form hills that are sinuous, and we can go and have a look at the sediment and see that it's different than a till landform like a drumlin. So a drumlin is formed when the glacier pushes and piles up till, which is material that has a wide range of grain sizes, from boulders and cobbles and sand and gravel, but it also contains a lot of fine material, silts and clay-sized particles. And it's also been compressed under the ice. So it's a very dense material. So let's go to Peterborough, Ontario, and compare material from an esker and material from a drumlin. So I've drove along. I've gone a little bit further north from the location I was recording, and I found the spot where the esker comes out on the next road over. All right, you can see we've got cobbles, well-rounded, some bigger pieces as well. Oh, lots of ants on that one. Got some bigger pieces coming up on the size of boulders. All right, but everything is well-rounded. And we dig into the sediment here. All right. It's very loose, sandy sediment. All right, and we take a closer look at that aggregate in there. Now, there's some angular pieces there, but a lot of them are quite well-rounded, and it's really sandy and gravelly. And that's what we expect when we're dealing with river wash sediment, is that it will be well-rounded. There'll be lots and lots of sand and gravel and very little clay material. And you can see we've got good evidence that this is glacial esker material. So we just had a good look at some sediment deposited in the esker. It was dry, loose material. I could really scoop into it very easily. So let's go and compare the material from the esker to that of a drumlin, which is forming sediment called till. Can you imagine glacial ice 2 or 3 kilometers above the landscape here? And it's pushing down towards the south, sort of in a south westerly direction. And one feature that forms under the ice as the ice plows along the ground surface is called a drumlin. A drumlin is made of glacial till. That's a mixture of large aggregate down to very fine aggregate like clay-sized particles. And it's really dense because of the weight of the ice is compressing it. And the drumlin is actually an oblong-shaped structure. And we can actually see this hill here has a gentle slope up this way and then a sudden drop. And actually multiple hills in a row have this sort of feature, and this is a drumlin field. One characteristic of a drumlin is it's made from till. We need to go have a close look at the soil. What we can see on the surface, we've got some rounded cobbles, all right, but they do have some angular pieces, and even here still lots of angular fragments. And that's what you expect in till, is to have a mixture, because some of the material could have been transported a long way and some a very short distance. But the key characteristic is that it's very dense material. So if we try to excavate at this here, it's really dense, really dense. I'm trying to dig in with my hands, and it's really compact. So it has some clay and silt-sized particles in it, and that's what you expect with till. All right, so you're gonna have these bigger pieces. You could even have great big boulders surrounded by this very dense and compact clay and silt-rich soil. There could be sand as well mixed in there. You'll have a wide grain size distribution. And if you're creating a dam, that's part of the engineering link, you could use the till as a core for your earth-filled dam. All right, so we just had a good look at some till. Very dense. I could barely dig that material out with my hand or even the rock. However, in comparison to the esker, which allows a lot of water to flow through it, the till doesn't allow water to flow through very well. And we can use those properties in different engineering applications. And that's the engineering link. Aggregate that allows water to drain easily through it. We often use that as filter material in dams or around our foundations to allow and remove the water from a certain location. And also underneath our roads that we construct, we have a base layer of aggregate, a subgrade, that we don't want any water form ponding underneath our road, because that will form ice lenses and that can cause destruction of our pavements. We want the water to drain away from under our roads. But in some applications, we want till. We want a material that doesn't allow water to flow through it easily. We can use that as a core and earth-filled dam to hold water back. We can use that as a clay cover on top of landfills and other locations where we want to protect the materials underneath from rainwater. And that's why it's important to understand the environment in which your sediment has been deposited. Thanks for watching.